And now we're going into the second half of our, the afternoon part of the agenda. We've got two things left on the agenda. The first one's going to be another talk from AT&T. Our very own Tuan is going to talk about the cell site router, which is pretty exciting. And then after that, Bill Carter should show up at some time. And then he and Jeff Sharp will speak to the Open Rack and Open Ops and how it can affect total cost of ownership for carriers. So if I can get Tuan up.
Hi, my name is Tuan. I work in the design group in AT&T that's in the Packet Optical. That's like the sister organization where Tom works in. So we deal with the backbone IP network, the cell site, the Ethernet backhaul, and also the optical packet transport. I only have 3 slides, so I was hoping that if you have questions and more interactive, so that I can answer some of the questions you may have about some of the design choices that we make. So AT&T, periodically, there's a refresh of equipment, and with 5G deployment, there's an opportunity to deploy new cell site routers in the backhaul. And this work started, I think, with our team. That's why I put the team there. A couple years ago, they started looking at requirements of what the next generation cell site would require. And the decision to go open with the white box things started sometime last year after, I guess, we did some proof of concept work with like Edge Core and Barefoot, that was Andre announced last year on a proof of concept on the white box, disaggregated NOS, proof of concept between San Francisco and New York on our backbone. So the team started to work probably July last year on a white box requirements. And so this is what, at a high level, what our cell site requirements are. So here is a diagram showing where the application is. It's basically this section, right? And so the access part is make it general, but mostly it's Ethernet backhaul. There's also direct connection with just point-to-point Ethernet. And then at the aggregation layers, there's also opportunity to do a white box at the aggregation layer. But here I'm just talking about these green boxes. So the interface that the cell site backhaul router is supporting is the IP over Ethernet to the BBU, and then uplink to the aggregation or 10 gig, 1 gig, or 100 gig Ethernet backhaul. So any questions here? So when we looked at this, there are a lot of white box out there, but the important thing for a cell site router is really the environmentals, right? It has to go into this GR 3108 class 2 outside plant cabinets, so that it needs to meet NEPS level 3 compliance. And it has to operate at a extended industrial grade temperature range from -40 to 65 degrees Celsius. The cabinet are typically sealed cabinet heat exchanger, and they're small size, so it has to be 19-inch, but the depth is shallow, so a lot of the existing white box out there are kind of too deep for it. Everything has to be front facing. All the fiber, the power has to be in the front of the cabinet, and the airflow needs to go from front to back. We like to have hot swappable fans and power supply with redundant power supply. So one of the important factors for cell site deployment is that the equipment itself is only a very small part of the total cost. The deployment of that equipment is also a major cost, and every time we have to do a truck roll to replace the piece of equipment, is very expensive. And I heard, depending on some remote location, it can be very, very expensive. Like somewhere in Alaska, you have to dispatch a helicopter. So reliability is very important in this piece of equipment. So we want to get lower costs, get open hardware, but it's very important that it has to continue to operate very reliable. And it has to have a lot of diagnostic capabilities so that our operation team can remotely troubleshoot the problem without dispatching a technician. It needs to support the timing, so it needs a bunch of circuitry to support all kinds of timing options. In the last picture, did I have yeah. So in here, typically the timing of our cell site is that there's a GPS, that's the primary time source. But then there's also a new requirement that there'll be backup timing from the more centralized over 1588, over the access network over here. So the cell site needs to have a timing circuitry that support all these different options in here. And then our current technology has about, 8 to 10 ports, and we needed more ports. I'm not sure our service team I think the plan is to move, if you support the existing equipment plus the new equipment, so there needs to be at least around 20 some ports requirement. And the port mixture has to be support, I think, all the way down from 10 megabits per second for legacy type of equipment, 100 meg, 1 gig, 10 gig. And then we wanted the uplinks to be 100 gig or 10 gig. And then the latest requirement that we just heard is that it also needs to support 25 gig to the newer generation of BBUs that our vendors are coming out. And they like that to be in the SFP 28, because that's more cost effective. Another thing is that the MACsec, initially it was thought to be a requirement, but when we dig into a little bit more, it's not clear if MACsec, because what happened is if we start putting MACsec at the cell site, then the aggregation layer that's consolidating all these thousands of cell site needs to support that. But so it's an optional, but one of the things that came up was support for long reach at 100 gig. And depending on the design, you either put the PHY chip there or not. So the way the Broadcom packaged their PHY chip to work with their switch chip, the MACsec came as free in the 100 gig. So that's why it's an optional thing. There's a BMC on board, and we recently put in a requirement for dual flash for the BMC. The BMC, right now we don't use the BMC, but I think going forward, the direction is to have the BMC there. And one of the advantages that we learned with the BMC being there is that it's able to control the temperature profile of the box. So we can actually start the NEP certification with just the NOS software may not be fully functional, but the BMC, because it's present and able to control the temperature of the box, we can start the NEPs compliant there. The dual flash on the BMC is that there was a question of open BMC and commercial BMC, and there were certain features that we needed that were not already, not developed on open BMC yet. So this way, with the dual flash, it allows you to upgrade the BMC at some point later in time. Okay. The Intel CPU, so we also put in a TPM module for security, in the future, and also upgrade with the dual flash. And the chip is a Qumran AX chipset with deep buffer. The buffering is required because of the Ethernet shaping that going over the different Ethernet carrier. It has to have those shaping feature and QoS. And here's a high-level block diagram of the spec. One of the things is the NIC here for the out-of-band Ethernet management is an I210 NIC. That's driven primarily by the software. AT&T purchased Viata software, and we'll be using the Viata software in here. And the way the Viata software is developed, it's DPDK. So the I210 is there. The DANOS is something that AT&T is working, with the open source. So eventually that components of that will be, the software will be open source. Yeah, that's it. You have any questions? Yes.
You mentioned the big buffer capability. How much buffer will be required for this?
I think, if I recall right, it was like 6 gig. Yeah. It's the Qumran has a standard, I guess. I think 6 or 8 gig.
So
the
buffering. Do you think that we'll have extra memory beyond what comes in the Qumran chip for buffering, or we'll just use the onboard?
No,
buffering?
this is the external buffering, so it's I think it's GDR
Mhm.
extra DIMM that we put in. So the important thing is all the components in here have to operate in that wire minus 40 to 65 degree temperature range. And I think the only component that is not available in the industrial grade is the BMC over here. So that would require a heater, an external heater. Yes.
Actually, two questions.
Yes.
First of all, the operational system. So you mentioned first that it will be Vayata-based software,
Yeah.
and then it's Danos. Okay, so when it will, because I understood that actually the Vayata will have some features which might be not open to Danos. This is kind of first question. And the second, whether it will be any difference in the operating system for UCP and for this device. It will be the same software, or it will be some kind of adjustment?
That, the UCPE AT&T uses also Viata software, and it's the same release train. They only have one development release train, and then we, for the SIAD, we work with the Viata team to upgrade, put in the feature list, in the different releases. So UCPE and SIAD, have a feature list. So it's the same Viata software. Now, the question on the Danos and the Viata. So what I understand is Viata has certain components in it that are licensed from other company, so we cannot open source that, right? So for us to open source it, the Viata team has to write an equivalent code for those feature and open source that one. But this project, because of the timeline that we have to meet for our cell site, we will be using the Viata software with whatever the purchase or the license component initially.
So did you say you were not going to support it in BMC?
No, so our operation team drove, the open BMC, but then they also want certain diagnostic capabilities at the same time. So open BMC, when we looked at it, I guess it didn't have those features set yet. So the decision is to initially go with a commercial, but over time, as OpenBMC have capabilities that will meet us, our needs, then we'll move toward that. So that's why, we built in certain things so that will allow us to upgrade to that path.
And the Intel version that you're looking for, is that like a Xeon D or?
It's there's a part number. It's the D1500 series, but the one that has the wide operating temperature range. Yeah. And I think it's Wayne here. Those, I think to get those that operates down there, it's the lower clock cycles.
And the need for optical bypass, is that required in any of your SFPs?
What do you mean by optical bypass?
So this is a small cell router that would be placed directly at the small cell site to manage things like S1 or X2 communications. And if you lose this box, would you have an optical bypass that would bypass the functionality of the box, or do you care?
I don't think there's optical bypass. So if there's something happen to this, so what do you mean by lose? Is it like completely lost power or something?
Exactly. So you want to make sure that you don't lose your S1 links or your X2 links. Because the system goes down, you have an automatic bypass function that you go through your optical. So
Yeah, there's no optical. Yeah.
that's the reason I ask, is that that's
Okay. I don't think our current system has that either. So if we lose the SIAD, we'll lose it, you know. But yes.
Yeah, about this Intel CPU, so you already mentioned this. Again, if comparing to UCP, it might be some models with 8 cores and 16 cores in order to provide the service chaining of different VNFs. So what kind of VNFs do you have in mind when you define these requirements for cores? What kind of software you plan to run there? Is it Mac or is it the Visual CU or what else? Because actually the rates are pretty high and you may need a lot of computational power unless this is just a control plane.
Strictly control plane. So I don't think there's a plan to spin up any VNFs in here. So within AT&T, there's also a security requirement. So if we start spinning up VNFs and stuff like that, these boxes, what we consider as appliance, would no longer be considered as appliance. They'll be considered as servers. So they fall into a different class of security device. So then they have to meet a much more stringent requirement, a lot of requirements on top. So we try to keep this like the traditional OEM box is appliance, just the NOS, and that's it right now. Unless there's some change, you know, from a security mandate.
So maybe you can give some example what kind of control plane for each functionality you consider running on the CPU.
Oh, so, you know, we run OSPF in a stub area with the aggregation layer. In this, let me go back. So these blue box here. So think of these blue box have a big collector circuit, like a 10 gig or 100 gig or multiple 10 gig collector circuit, and you build EVCs down to the green box. So they run OSPF with the blue box, and then BFD, keep alive with that right now. But that routing design is also being changed in the future, so that, you know, we don't have to run OSPF, maybe just do BGP, slim down the control plane. But the existing stuff are OSPF. Have any questions? All right, and that's it, I think. So I guess the next step is for us is to, for me, is to submit this as a spec to OCP and go through the process of review. And I'm working on a few other projects that's also white box, you know, like the blue box, the aggregation layer also. So if we look at that, you know, there are white box out there, but the requirement is, you know, for that blue box, it needs to support a lot of control plane sessions and stuff like that. So basically it's fine-tuning those requirements that needs to meet the carrier use case. All right, I think that's it for me. Thank you.